Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, TuneIn Radio, or add an RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, with links in the show notes. And please give us feedback. You can leave us a review on iTunes, send us a tweet, send us an email, leave us a message on Google+, or leave a comment on our show notes. Leaving a review on iTunes will help other people find our show so that they can enjoy it as much as you. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. I would also like to thank Hired, a job marketplace for developers, for sponsoring this episode of Podcast.init. Use the link hired.com/podcastinit to double your signing bonus. Linode is also sponsoring this week. Check them out at linode.com/podcastinit and get a $10 credit to try out their fast and reliable Linux virtual servers for your next project. We are recording today on October 27th, 2015, and your hosts as usual are Tobias Macy and Chris Patty. Today we are interviewing Dariusz Suchojad about Zato. Dariusz, could you please introduce yourself?
Hello everyone, I'm Dariusz. I'm a systems architect, a programmer, and a primary author of Zato, which is an integration platform and backend and API server written in Python and designed from scratch with Python programmers in mind. That's what I do.
That's great. So how did you get introduced to Python?
Some 15 or 16 years ago, I was reading a book on Java. The book was called Thinking in Java. And at one point, the author mentioned that one should definitely have a look at Python. It got me curious because it was a book on Java, and here the author is mentioning another programming language. So I paused the book, downloaded Python, and actually I never get back to that book again. And I just stay with Python. Though eventually I did spend several years using Java as my programming language, so 5 or 6 years. But Python has always been the only language I was truly able to express myself in. It's the only language that I just feel it lets me fly. It's the only language that doesn't force me to work around it. Instead, I can work with the language to achieve a given result. So, despite being a polyglot programmer, I consider myself a Pythonist primarily.
And so, does your time in Java, is that what inspired you to create Zato in the first place, or gave you the idea?
Well, yes, you can say so, because my background, what I've been doing for some 15 years is enterprise applications integration. So it's the domain that typically sees Java in use. Java or C, C++, some .NET, and the score of proprietary 4GL languages. And at one point, I simply had enough of it. I understood that Python was the very high level language that would be great for what I was doing, except that there was no platform for doing it. Everything was either in Java or C or C++. So someone simply had to do it, and it turned out it was me. And at one point, I simply quit my job, sat down to work, and created Zato after some 2 or 3 years.
And can you give a more in-depth explanation of what Zato is and what makes it stand out from other Service Bus implementations?
Well, Zato is an integration platform. It's a dedicated piece of software. It's a piece of software dedicated to integrating other applications. So if you're doing something like calling several REST endpoints, combining the responses and reaching out to an AMQP AMQP broker and collecting some responses again that are transformed into XML or JSON depending on what the output format is required in a given situation. Then Zato is a software that simplifies the process. And you can do all the transformations, you can establish all the connections straight from Python. It's a platform which offers a lot of adapters to actual technologies like AMQP, ZeroMQ, Web3MQ, REST, SOAP, Cassandra, SQL, there's a lot of it. So that in your code, instead of thinking about how to connect to a given technology, you are basically given a dictionary on input, and you need to provide the framework with a dictionary on output, so that someone calls your code, the code is exposed through an API, which can be a SOAP API, it can be a REST API, it can be an AMQP, but no matter what the transport, no matter what the technology it originally is, you in your code receive a dictionary, a Python dictionary, or it can be any other data type, but it's simply easiest to work with dictionaries in Python. So you get the dictionary, you extract some data from it, provide it on input to a call to an external service like another endpoint. You take the response and provide some interesting and useful output out of it all. That's about what integration servers are about.
And can you describe some of the ways that you have architected Zato to be able to have appropriate performance characteristics for being able to ingest and send data out from multiple different endpoints and be able to do that in a scalable manner?
Right, so Zato is based on G-Event, which is based on lib event. And to be precise, Zato uses G-Unicorn, which is a very scalable server in Python that lets you leverage multiple CPUs, yet at the same time, it's a so-called asynchronous server. So you can accept a large number of TCP connections, despite there being only a handful of CPUs. That's how the core networking part works. Each Zato environment is one or more clusters. So there's a built-in load balancer to distribute the traffic across multiple servers in case one server is not enough. And you can have as many servers as you need, as many servers as are required to handle a given traffic and throughput. Another point is that in Python, two most commonly used data formats are XML and JSON. And in Python, we've got the excellent LXML library to deal with XML, and there are libraries to quickly process JSON. Both libraries are written in C. So essentially, despite being in Python, the core loops, the core parts run at C speed in Zato. So in case anyone was wondering if Python is fast enough for that kind of software, yes, it is. Because it really runs at the speed of raw C. So there are fast libraries for parsing the messages. There are servers. Servers can use as many CPUs as you give them. Plus, there's a load balancer in front of all of the servers, so you can scale, to any level that's required. And if a single cluster is not enough, you can have as many clusters as you need. So that's how the scalability works. You can scale to any needs.
Does Zato perform well in restricted resource environments like EC2? What performance bottlenecks are common when using Zato?
Well, honestly, I'm not aware of any performance bottlenecks when using Zato. Like like I just described it, you can have as many servers as you need. You as long as you've got a Linux system, as long as it's Ubuntu, Debian, or CentOS or Red Hat, you can scale it to any needs. So it performs very well regardless of what the environment really is, as long as it's a Linux system. So it definitely runs on Amazon, or you can run in your own data center. It doesn't really matter. It doesn't need much resources. It's fast enough for many needs.
That's great. I mean, just to give you a sense of why I asked the question, both Tobias and I worked at a company where they used Red Hat's, Java integration platform, Camel. No, that's the protocol. But in any case, it used a Java-based ESB, and it worked great. But it unfortunately had this tendency and this habit of consuming all available memory and CPU on the EC2 nodes that we were running on, effectively crushing them to death. And so that's kind of why I was asking what kind of resource constraints Zato ran well under.
Oh yeah, I understand how it's possible, but yeah, in Zato you a single server running using a single CPU in idle state will use about, up to 100 megabytes of RAM. So that's how much it needs right after it started. And I am aware of a few environments that's been running for about 2 years now on something like a gigabyte of RAM, and they simply work. They simply work. They've never been restarted, and it's all fine. So it's very good as far as the resources go.
And so you mentioned that those instances have never been restarted, and I know that reading through the documentation, Zato supports hot code reloading. So can you delve into that a little bit about how the reloading works?
Right. So I've been always impressed by how Erlang works. I've heard this. I've never used it really, but I've heard that it's possible to replace code on Erlang servers while they are running. I thought, why shouldn't we have it in Python? If we don't have it in Python, the language, why shouldn't we have it in Zato? And so the way it works is that a service, because everything in Zato revolves around services. A service is a piece of functionality which essentially accepts some input, produces output. It's like a function. It's just like a regular function. It's just that it's distributed across multiple servers and can be made available across multiple APIs. So the hot reload feature is essentially the ability to delete and replace old functions with new ones, old services with new ones. So during development, you edit a file, a Python module, you hit save, the file is stored in a so-called pickup directory, and the background process understands that there's a new file in this directory. The file is picked up, transported to all of the servers in the cluster, and immediately available everywhere. So you don't need to restart servers to take advantage of the new code. Same goes for configuration. You don't need to restart anything after changing anything. If you've got new credentials for a given input channel and you update the password is automatically made available throughout all of the servers. Same goes for any API endpoint you add, delete, edit, or change in any way. So I don't particularly like restarts. I've seen far too many instances that servers won't boot up again after a restart, not because something changed as far as servers go, but something can always go wrong as far as the operating system goes. Why restart everything if we can only replace the parts that we need to replace within the whole server? That's one school of thought, because there's another school of thought which says that we should always restart servers because that in that way we can make sure that both operating system and the server always have access to the latest updates as they become available. That's what people do with Docker files, for instance. So that's also possible. We also have Docker files for each of the Zato component, like servers, load balancer, or web admin. But it's extremely convenient to be able to simply hit save and have the code available on all of the servers, or simply click in the GUI, click update password, and not have restart anything. It's a tremendous productivity boost. So that's something I really like to use.
Yeah, being able to do automatic code reloading definitely sounds like a very useful feature, and I'm wondering if you have made that available as a standalone module for people to be able to use in other systems.
Well, it's part of the framework, so the answer is no, and it won't handle any arbitrary changes. The mechanism is aware only of the Zato services, so it's because there are always complications because I thought of it, but it's not that straightforward. If you've got, for instance, live TCP connections to a remote server in a module, on the global level, what do you do? How do you reload it? And so if you give users the ability to hot reload everything, you will at one point need to handle literally everything. So, and then how do you deal with such cases like live connections to servers? Well, you cannot do it without the cooperation from users. So it's right now it's limited to Zato servers, which is what the Zato platform is about. So it's not any real limitation.
And it seems that most other integration platforms are written in Java, and I'm wondering what advantages Python has over Java for this kind of a project, and in what ways might it be inferior?
Well, the number one reason is that Python is on a higher level than Java. So in this kind of projects, the productivity is what is most important. The ability to quickly, swiftly react to ever-changing requirements is of utmost importance. So the dynamic nature of Python is what sets it aside from Java, and that's the advantage Zato has over non-Python solutions. And as far as disadvantages go, several years ago, I would say it was a bit problematic to use Python in a few places because proprietary vendors were simply accustomed to use either Java or .NET, C or C++. You had some COBOL, and that's pretty much it. But nowadays, it's disgraceful and shameful not to have at least a SOAP API, or not to mention a REST or a RESTful API. So I cannot really think about any disadvantages to using Python for such a platform. Even if there isn't a client given server-side technology, these days the technologies themselves will have a SOAP or REST API, so you can connect to anything, which wasn't exactly the case some 5 or 6 years ago, but now it's way more convenient to connect to even proprietary technologies from Python.
And so the architectural nature of integration platforms are such that they form the central backbone of a software system. And I'm wondering how you've been able to ensure an appropriate level of reliability and stability in the Zato project while still being able to deliver new features and improvements.
Well, right now we had a major upgrade from the initial release to the newest one. There are a lot of internal changes. So right now, if you had a Zato 1 environment and you wanted to upgrade it to Zato 2, you needed a full shutdown. That's how it looked like. However, right now, any new features added to the platform, don't assume that there will be a full shutdown at any point. So everything is able to gracefully handle situations where, for instance, the configuration database changed between any calls to your service. So, for instance, let's say you've got two servers in an environment and you want to upgrade it to a newer version. You can indicate on the load balancer that one of the servers is down for maintenance, upgrade the server, start it back, and the server, despite being in a newer version, will simply continue to handle the traffic. And then you can take the other server down, upgrade the binaries, restart it, it will simply work. That's how it can work. And of course, you can always use Docker files, where you can simply replace the old files with new ones. So you won't even have to restart any service. You will restart the whole operating system, but the whole container. So that's how it looks like. So you can replace the binaries on each server separately. That's how it will look like in new releases.
So how do you do that? I realize it's a perhaps overly simplistic question, but thinking of my own Python programming, I think about the parts of my programs and the classes that interrelate. I've got to imagine that there's some extra architectural secret sauce that you used to enable that capability. Can you give us some details of what that was?
Well, everything is Zato internally is based around services. It's a service-oriented architecture, and there are not that many dependencies in the Python sense. That we've got modules, we've got internal components, but everything is really a service. So a service can handle it's coded in a way that understands that some data may be missing because it was added in a new version. It makes the code less convenient to develop, but it's all for the purpose of people's having, less downtimes, if at all. Plus, on top of that, we use Redis extensively. So it's a schema-less database. So even if the schema changes, then there is really no schema. So two versions of the same service can happily live with the same Redis database. And if something is missing, then it simply won't be possible to use it. If some data in the database is missing.
So just so I can understand you correctly, you were saying you use the Redis database, right? Okay, thank you.
So I was going to ask about how the scalability story works, if there's any sort of auto-discovery that Zato does in terms of being able to scale out clusters, or if it needs to be explicitly set in any configuration file, and just wondering how dynamic you can make your Zato clusters.
Well, no, there's no auto-discovery mechanism. I contemplated if it should be added. Yeah, because it's convenient to have it at times. On the other hand, it could be a security issue that that someone can simply start a new server and make it join the already existing cluster. So I'm sure it can be worked around, but at that point you simply need some sort of manual configuration. So if it's needed, you can as well just not use the auto discovery mechanism. So right now, if you let's say you've got two servers and you'd like to add another one, you start it, you point it to the cluster, but you need to do it from command line manually, and then you log into the web admin and point the load balancer to it, because there's never any traffic from servers to the load balancer. So the load balancer needs to be told that there's a new server it can direct traffic to. So that's how you can scale it up. But no, there's no auto discovery.
So does Zato run well under PyPy?
Well, I've never really tried it. It would be a nice exercise because it sounds like a great application for PyPy. There are parts of the platform that, they've been stable for several years now. What they do is go through a list of headers or anything like that, which there are perfect use cases for a just-in-time compiler. But no, I've never tried it. And I guess I should at one point. But no, I just don't know right now. It could be a fun exercise. So I hope it would run great. And I don't think that there are any SciPython specific features we use. So as long as we can get PyPy running, I don't see why it shouldn't work and why it shouldn't speed everything up.
And so for anybody wanting to use Zato, what are the infrastructure requirements for deployment? So you mentioned Redis. I'm just curious in terms of how the overall deployment story works. Can you run it on a single instance, or do you need multiple instances for it to be able to operate properly?
Right. So the only requirement is the Redis instance, and plus you need a Linux server. You need Ubuntu, Debian, or CentOS or Red Hat, and that's it. That's it. We are even thinking about replacing Redis so that Zato itself would be enough. I think a Linux server is enough. We've got the command line interface, and one of the commands is quick start. It's called quick start, and invoke it like Zato quick start creates path to a directory, and it sets up a working environment consisting of two servers, load balancer, and the web admin. And that's how you can get started in 5 minutes. You just need a Linux plus this command. And there are environments that are simply quick start environments renamed to development or user acceptance tests or production, and they work just fine. There's no need to distribute the servers across multiple instances, like multiple operating systems. If a single server is enough, or a single operating system is enough, then it's enough. You can always add servers on additional instances and make them join the initial cluster. So that's how it works. You create everything from command line, and then in the web admin you point the load balancer to new servers, and then everything simply works. When a server starts up, it reads up all of the configuration pieces. If you, for instance, take a server down and deploy new code when it's down and bring it up after a week, then the new code will also be read in, so that the state across the servers in the cluster is always in sync. Everything is always in sync. You only need to add servers from command line, and you can scale to any level, really.
That's great. So what are some of the security ramifications you took into account in Zato's design?
Well, so as you can see, Zato is a set of servers exposing TCP connections and TCP ports and establishing TCP connections. So the really critical commands are done from the command line. So you cannot just be given web admin access and add or delete servers in a cluster. You need SSH access to the system. So only then you can extend a cluster. Plus, every TCP connection can be behind TLS. So it's encrypted. The traffic to the load balancer, including client certificates, the traffic from the load balancer to servers, from servers to external systems, everything can be encrypted. Plus, we've got a policy of there being no default passwords, including no empty ones. So we go to great lengths to ensure that any sort of password is either generated automatically and set to a UUID, or if there is, or users are given instructions how to generate it. So now, for instance, a colleague of mine is preparing images for Amazon Beanstalk, and one of the things he'll be doing is to ensure that on the first boot, password to the web admin is automatically set to a UUID, so that we don't have any default passwords on Amazon images. So you need actual SSH access to the command line to prepare to invoke the crucial commands. Plus, on the transport level, everything can be encrypted. Plus, there are no default passwords. On top of it, we've got several security mechanisms to secure the APIs themselves. We've got API keys, NTLM. It's used when invoking SOAP services on Windows. We got basic auth. We also got, for instance, role-based access control. So that on top of granting credentials to applications connecting to your platform, you can group the applications into roles. For instance, let's say you provide an API for a banking system, for a central banking system. You can grant some applications the role of account reader, but not account updater. For instance, so that a given application will be able to check your account balance, but won't be able to update it in any way. And the roles the applications are in can be inherited. You can have a tree of roles, and then instead of thinking, does that application have access to that backend system like this banking system, you instead think, what roles should I use? What roles should I grant to a given application? So it's actually mapped to HTTP verbs. So you can create is post, read is get.
So what are some of the most novel uses for Zato that you have seen or heard about?
The project I am on right now, because it's really built around the service-oriented architecture. It's a project in healthcare, and we're building a healthcare integration platform. We're integrating with some 6 or 7 systems, and everything is a service. So that instead of implementing a given workflow, that is needed to put on front end or in front end, we add services that can be used by the front end to drive the user through a series of screens and forms.
So last thing we usually ask is, are there any questions that we didn't ask that you think we should have, or anything that you wanted to mention that we didn't bring up yet?
No, I think it's fine. No, it's cool.
Okay. So with that, we'll go into the picks. And so my first pick today is a movie I just watched last night called Spy. And it's a slightly different take on your usual CIA operative movie. So it's just a very well done action comedy that I thoroughly enjoyed. So definitely worth taking a look at. And my next pick is Eric Royer's One Man Band. And this is a gentleman who has created a setup that will let him play a banjo, an acoustic guitar, and a dobro all at the same time, and he's very talented at it, so definitely worth taking a look. And my last pick is going to be a Python library called Pip Tools, which lets you write your pip requirements as a requirements.in format without having to list out all the different versions and all the different dependencies at the same time. And it will then take that of just the high-level requirements that you have, retrieve all of the dependencies and their versions, and then output that to a requirements.txt file so that you can pin all of the versions of all of your dependencies at deploy time so that you don't have any surprises when you're going to deploy, but you can also still manage your requirements in a much more sane fashion. So definitely been enjoying using that recently. And with that, I will pass it on to you, Chris.
Very cool. Thanks, Tobias. So my first pick is a podcast. It's kind of unusual for me in that it has nothing to do with technology or art. It's called Rational Security, and it's by three people who are researchers at the Brookings Institution, which is a centrist think tank. The podcast is about American security, which sounds kind of nebulous, but basically it is a podcast about the American interest from a security perspective in world affairs. And it's really, if you're someone like me who tries to keep abreast of the news, it's really very interesting. It takes a number of stances into account. They're incredibly smart people, and I just find myself learning a lot with every episode that I listen to. Great stuff. My next pick is another podcast. It is called the New Rustation Podcast. There's another guy named Chris who runs this, and he is doing an exceptional job. There are a lot of sort of, learn programming language X podcasts cropping up now, and I don't think many others of them that I have heard are doing as good a job as Chris is in terms of the way he's thought out his episode content. His presentation style is very clear and crisp. I really feel like I get a lot out of each episode. And given that I myself am learning the Rust programming language now, it's very timely. So do definitely check him out if you are learning Rust. And if you do any kind of low-level programming at all ever, or even find yourself thinking that it would be neat to have your Python programs, run more quickly in certain spots, then rather than reaching for C or C++, you should probably consider Rust, and so his podcast could be of assistance. My final pick is a drink, which I learned about at a really phenomenal bar that we have in the Boston area. To call it a bar is kind of damning it with faint praise. It's called Drink. It was voted in the top 50 bars in America 2 years running now. Actually, maybe even 3. But in any case, I tried a drink there called Johan Goes to Mexico. It's a really interesting cocktail that's made with mezcal and a whole bunch of bitters. And mezcal, I don't know if you've never had it, is this incredibly smoky, intense alcohol variant that is somewhat akin to tequila, but so smokier and more savory, if that possibly can make any sense. But this drink, you get the smoky hints of the mezcal, but it's balanced nicely by the sweetness of the bitters. It's really delicious, and I included a link to the recipe, so you too at home can give it a try. Dariusz, if you have any picks for us, now would be the time. If you don't, that's perfectly cool as well.
Well, about the only pick I could offer is that, I definitely recommend giving the Sublime Text editor a try if you are into a new Python IDE. So I'm a long time Wing IDE user, but I'm always on the lookout for new tools to increase my productivity. And despite not being an actual IDE, I am very impressed with how fast and how convenient for a programmer Sublime Text is. I was aware of it like a year or 2 years ago, but now I believe it's gotten even faster, and it's definitely worth checking out if you're not using it already. So, or even if you already have an IDE, it's always nice to have another editor on the side, and Sublime Text could be it. That's my pick.
All right. Well, thank you very much for taking the time out of your day to join us and tell us all more about Zato. And for anybody who wants to keep in touch and follow what you're up to and the progress of the Zato project, what would be the best way for them to do that?
Well, please visit zato.io, and we're on Twitter, Zato Source, on GitHub, Zato Source, and there's a mailing list, but everything starts at zato.io.
Excellent. Well, we appreciate your time, and I'm sure that our guests will enjoy learning more about this project, and I'm sure a number of people will be happy to know that it exists so that they can either extend their current architecture or perhaps replace some Java that happens to be running in their stack somewhere. So I appreciate your time, and I hope you enjoy the rest of your day.
Okay, man, thanks. Take care, everyone.
Thank you. Bye-bye.